So this assignment is about the waves, overall journal waves, and with answer key as well. So here, student perform an experiment to investigate how the speed of the wave on a stretch string affected by a tension. How student vary the tension by adding a load here. By changing a load, the tension will change, and it will produce a pattern, as you can see here, basically a standing wave. And how these standing waves are produced when two progressive waves are traveling in opposite direction, it gives rise to a standing wave. Some region they increase the effect of each other. So the region where they increase the effect of each other will get nodes, and the region where they decrease the effect, region where they increase the effect of each other, antinode, and decrease the effect of each other, node will be there. For a particular mass, a student adjusted the frequency of a signal generator until a standing wave is established. And student find from A-level textbook that P is equals to under root T divided by mu, where mu is a mass per unit length and T is the tension. Student decided to see if the data supports the expression. She started to process her data and plot it on a graph. Use the information in the table to add two more points on the graph, record the result, and draw a best fit line through the points on the graph. And do the student results support the relation given above? So the relation which is given above, V is equals to under root T divided by mu. So as you can see, this expression mu is also a mass per unit length, which is a constant. So if V is equals to under root T divided by mu, if I square this, so I can say V square is equals to T divided by mu. Or V square is equals to 1 over mu into T. So if I plot a graph, Y is equals to mx. On y-axis, if I plot V square, or on x-axis, if I plot T, what will be the grade? Because 1 is constant, mu is also constant. So the gradient will be equal to 1 over mu, or gradient will be constant. So if gradient is constant and there is no y-intercept, so it will be a straight line which is passing through origin. So this should be a straight line which passes through origin. That will be the graph. Or you can also plot a graph between V and under root T, the tension. Then 1 over under root mu will be the gradient. So if I have y is equals to mx, if I have on y-axis, if I plot v, and on x-axis I have under root t, again my gradient will be a constant, so it will be a straight line which is passing through origin. So any one of them you can complete, plot a graph. So if I'm normally, because it's easy to do a square rather than taking a root of the quantity, so it will be v square is equals to 1 over mu into t. So we need v square and we need t. So we have v is equals to f lambda is there. So here we'll have v, which is equals to meter per second. Then we need v square, which is meters per second square. And then we will have T, the tension, and the unit will be newtons. Is it clear? The columns, how we complete?
Yes, sir.
Then the next part, we just have to get the value. How to get the value of V? We multiply them, like 30.6 multiplied by 0.37. So we have to complete this. So 30.6 multiplied by 0.37, it will be 12.3. And then we will square this, so it will be 151. And then tension. How we'll get the tension? Like if the mass per unit length is the mass is given kilogram. Tension, basically the weight is a tension. So if we have 0.16, the mass is there, we need the weight. So weight is mass multiplied by gravity. And that weight is a tension. So mass is 0.16 and the gravity is 9.81. So we multiply them, we'll get the tension. So this will be 1.96. Same way, when we multiply 30 multiplied by 0.41, so it will be 11.3. And you can see it is 30.0. It's written because you should have the same number of significant figures in each column. So it is very important that you work on this, like using the same number of significant figures. So this will be 1.57. And then we will plot a graph between V square and T. So when we plot a graph between V square and T, so it will be a straight line which is passing through origin. And if it's a straight line passing through origin, it means that the relation is correct. And it should be right, because it should be a straight line passing through origin. Then use the graph, determine the value of mu. The graph is here, the graph for V again, graph of V square against the T is there. So this graph will be like this. You will draw best with straight line and find the gradient, because this is the y-axis. I tilted the graph just for the space. So it is V square is equals to 1 over mu into D. So when we compare y is equals to mx on y-axis, like this is a y-axis. I tilted the graph. This is actually a y-axis, and this one is a x-axis. T is the x-axis. So how to get mu? 1 over mu is gradient is 1 over mu. So mu is equals to 1 divided by gradient. So we'll take the 2 points. Anywhere we can take 2 points, and y1. First point on y-axis will be y1. Second point on y-axis will be y2. First point on x-axis will be x1. Second point on x-axis will be x2. So we'll find the gradient, and reciprocal of the gradient will give us the value of mu. Is it clear? Question 1?
Yes, sir.
Okay. Then babies' food sometimes carry the following warning: do not feed in a microwave oven, as they may cause an uneven heating and could scald your baby mouth. An internet site gives the following explanation: the coherent microwaves which are emitted in all the directions from the source within the oven, they are reflected from the metal wire, so that the microwave radiation reach at any particular point arrive from several different directions, and the waves will interfere, setting up the standing wave. So basically what happened, like if this was a microwave oven and this is a source of the microwave, so it is producing microwaves in all the directions. So these microwaves reflected from the wire, like maybe you have seen that the inside part of a microwave oven, there is a net of wires, mesh of wire. So the microwaves are reflected multiple times from these wires, and they meet at different points. Like different types of microwave meet at different points. So some points, if there is a constructive interference, they increase the effect of each other, that region will be hot. But some regions where they decrease the effect of each other, cancel out the effect of each other, that region will be cold. That is the reason in a microwave oven, you will always find that there is always a turntable. Like when you keep the food inside, you place it on a turntable or a plate, and that plate is continuously revolving, rotating. So what is the reason why this plate is rotating? Because maybe this region, there is a constructive interference, so that region will be hot. But another point where there's a destructive interference, that region will be cold. Then another point, there will be hot and cold. Like hot and cold regions will be there due to a constructive and destructive interference. So it will have uneven heating. Like some parts it will be hot, some part it is not. So how it can overcome this problem? By rotating the food on the turntable, so that all the parts will receive the same amount of heat energy, or all, like there will be no part left in the cold region, all will be there in the hot region or continuously moving from hot to cold or cold to hot. So explain the meaning of coherent. So what is the meaning of term coherent? The term coherent means that the wave is having a same frequency or same and constant relation, phase relation. So the definition of a coherent, that the waves having same frequency and constant phase relation. That is called coherent. And what is the meaning of standing wave? How we define the term standing wave? That the standing wave, the wave which is formed by a superposition or interference of two waves which are traveling in opposite direction. So wave produced by combination of two waves traveling in opposite direction produced nodes and antinodes. So when nodes and antinodes are produced by combination of two or more waves, we call that as standing wave. On the diagram above, mark a possible position of one antinode and label that as A. Where is the antinode? Antinode means where there is a constructive interference. So where is a because this is a hot zone. So hot zone is the constructive because they, so this will be antinode. And if they ask mark a node, because cold zone means they decrease the effect of each other, so you can mention as a node or you can mention node. Then antinode. So you can mark anywhere, but as we have to just mark antinode, so we mark at the center of. The frequency of a radiation used by microwave is 2.4 into 10⁹ hertz. So that the wavelength is about. So all the microwaves like electromagnetic wave, they have a constant speed 3 exponent 8. So we have the formula V is equals to F lambda. So where V is the speed of the wave, which is 3 into 10⁸. Frequency we don't know. Frequency is known. Wavelength we don't know. So multiplied by wavelength. So when we divide, we will get about 0.12 meter, which is 12 centimeter. Is it clear? This part?
Yes, sir.
Okay. Then the diagram shows two different paths of microwaves. Find the path difference of a wave at point X. So this is a point X, like where they interfere. So this covered first 20 and 10, and this covered 22.1 and 14. So the total distance is 30 for one, and total distance is 36.1 centimeter for the other. When we subtract, because of part difference, when we subtract, so it will be 6.1 centimeter. And the wavelength, look, the wavelength as we already calculated was 12 centimeter. If wavelength is 20 centimeter and the distance we are getting 6.1, so what is the part difference? The part difference is half of the wavelength. Because normally when we represent the part difference, we represent in terms of wavelength rather than just writing a number. And if the part difference is half wavelength, what kind of interference will occur? So there will be a destructive interference, and as a result of destructive interference, it will form a node. So here, assume that the wave do not reach point X along any other path. Explain what you expect, node or antinode. So what we expect node, because there will be like anti-phase. So there will be a destructive interference. The two waves will cancel out the effect of each other. Some microwave oven used to separate the microwave frequency to overcome this problem of uneven heating. Explain how this helps. Like two separate microwave frequencies are, because when the frequencies are different, that interference cannot happen or occur. So if two microwaves having a different frequency, so that they will not interfere with each other. So when two waves having different frequencies, cannot interfere with each other, so it does not produce pattern of nodes and antinodes. So if the two waves which are produced here, like if one wave is, say, the frequency of gigahertz are there, for example, if the one wave is 2 gigahertz and another wave is, like example, 3 gigahertz, so they will not, even though they are coming at this point, but they will not interfere, because for interference the two waves have a comparable frequency or a wavelength. If they don't have a comparable frequency or wavelength, they will not interfere. Same thing, like sound waves are a different frequency of the sound cannot interfere, or different frequencies of the electromagnetic wave cannot interfere with each other. Is it clear?
Yes, sir.
Okay. So this was an assignment related to topic waves.